Chemical Kinetics, presented by G. Satyanarayana Gowda, Assistant Professor, Department of Chemistry, Dr. BRR Government College, Tirchatla. Today we discuss about the reaction rates and factors affecting the rate of reaction. Before discussing these concepts, we say that the physical chemistry is having two important branches. Among that, many important branches. Among that, thermodynamics and chemical kinetics are the most important pillars, we say, pillars of physical chemistry. Thermodynamics explains the feasibility of chemical reaction, whereas the chemical kinetics will explain that will deal with rate of reactions. The chemical kinetics also deals with the mechanism of chemical reactions. So what is meaning of mechanism of reaction? What is the meaning of rate of reaction? What is meaning of order of reaction? Everything will be discussed in chemical kinetics. Today we discuss about the concept of reaction rates. Means what is the meaning of reaction rate? How the reaction rate is expressed? Then how to determine the reaction rate that we discuss. Let me see the rate of reaction. During progress of any chemical reaction, what happened? The concentration of reactants gradually decreases. The concentration of chemical reaction gradually decreases. Reactant decreases and the concentrations of products increases simultaneously. Means the reactant gradually converts into products with time. Greater the rate of disappearance of reactants, greater will be the rate of appearance of products. Correct or not? Greater the disappearance of reactants in the chemical reaction, greater will be the formation of products. Suppose if you are comparing two reactants, one let's say A gives B, second say suppose C gives D. A gives B, C gives D. In A gives B, A is the reactant. In 5 minutes, suppose in 5 minutes, 1 mole of A is participating in the reaction. In 5 minutes, 1 mole of A is participating in the reaction. Let us see the another reaction. What is the second reaction? C gives D. In C gives D, C is the reactant. Now, in the same 5 minutes time, 3 moles of C is disappearing. 3 moles of C is participating in the chemical reaction. But in the first case, only 1 mole of A is participating, but here it is 3 moles. Means where the formation of products will be more. We can say easily that in second reaction, more quantity of products will form. Means we say the speed of reaction is more in case of second reaction, like that. So, during the progress of the chemical reaction, the concentration of reactants decreases, concentration of products increases. The speed of reaction is expressed in terms of concentration change of any substance that present in chemical reaction under given conditions. So the speed of reaction or the rate of reaction expressed in concentration change. Greater the concentration change of reactants or products, you say greater will be the rate of reaction. Greater will be the speed of reaction. That is the meaning. So let's say how to express the rate of reaction, how to write the rate of reaction. You remember the rate of reaction expressed as what? Change in concentration of a species divided by time. Change in concentration of a species divided by time. Let's consider this reaction. What is that reaction? N2 plus 3H2 gives 2NH3. How to express the rate of reaction? Do you know? This reaction involves in which process? It involves in Haber process. In this reaction, 1 mole of nitrogen is reacting with 3 moles of hydrogen to give 2 moles of NH3. When you are expressing the rate of reaction, in terms of concentration change, we have to express always per 1 mole of substance that involved in the chemical reaction. We have to express for what? Only for 1 mole of substance that involves in the chemical reaction. How many moles of nitrogen is there? Only 1 mole. Hydrogen is 3 moles. Ammonia 2 moles. But you have to express the rate of reaction for only 1 mole of substance. That is the first point. Second point is you can express the rate of reaction either in case of any substance that present in the reactant side or in the product side. Means with respect to any species that involving the chemical reaction, you can express the rate of reaction by using what? The concentration change per time. So when you are writing the concentration change per unit time for small time intervals, we can use the differential equations like this as we shown here for this reaction. You see, N2 plus 3H2 gives 2NH3. So nitrogen is a reactant that is consuming in the reaction. When you are expressing the rate of reaction with respect to the reactant, you have to write what? Negative sign before it. You have to write negative sign before it. You have to represent that. So how many moles of nitrogen is there? Only 1 mole. Next, you see, how many moles of hydrogen is present there? How many moles of hydrogen is there? There are 3 moles. But you have to express for only 1 mole. When the 3 moles of hydrogen is existing, now you are going to express for 1 mole, means 1/3 you have to consider. It is also a reactant, that's why you are writing what? Minus. Since 3 moles is participating, you have to write a reciprocal of it 1/3. Means an existing quantity, you are taking 1/3, means it is equivalent to 1 mole. So minus 1/3 d of concentration of H2 divided by dt. That is equal to NH3 is forming in the reaction, it is the product. How many moles is there? 2 moles. When you are expressing for 1 mole, you have to write what? Half of it. Means 1/2 of d of concentration of NH3 divided by dt. You remember the square brackets indicates molar concentrations. Whenever you write this type of square brackets anywhere, it indicates what? Molar concentration. That is very important, you have to remember. Here one question is, why you are writing minus in case of reactants? Why you are writing plus in case of products? So we say that why we can write minus because the reactants are consuming in the reaction. That's why the concentration of reactant decreases. That's why you have to write minus. The products are forming in the reaction. They are accumulating in the reaction. That's why you are writing plus. That is one of the concepts. But actually we can explain that like this. For example, nitrogen we have taken. It is a reactant. The initial concentration of nitrogen is, for example, it is 10 moles per liter. Whereas in the final, it becomes what? 4 moles, for example. 4 moles we have taken. This is the initial one, whereas this is the final. Whenever you are calculating the concentration change, what we write? Final minus initial. Means what we write here? 4 minus 10. What you get is, we get with the negative value. We get the negative value here. Means when you are writing concentration change, in case of reactant, you will get the negative sign. But the rate of reaction is always positive, remember. In order to express that positive sign, there you have to include what? Negative sign before the expression. So the rate of reaction in terms of concentration change is expressed like this. First point, you have to write negative sign before the equation represented for the reactants. You have to write positive sign when you are expressing the rate of reaction in terms of products. First point. Second point, you can express the rate of reaction with respect to any one of the substances that involved in the chemical reaction. That is second point. Third point, you have to express the rate of reaction for only 1 mole of substance. Means if n moles is participating in the reaction, you have to represent how 1 by n. Simply we write the reciprocals of stoichiometric coefficients. So in this equation you see here, what is the relation established? What is the relation present between this nitrogen and hydrogen? In this expression, minus d of n2 divided by dt, minus d of n2 divided by dt here. Just we are not considering this 3. Just we are writing what minus d of n2 concentration divided by dt. This minus d of n2 concentration divided by dt is nothing but it is rate of disappearance of nitrogen in the reaction. It is rate of disappearance of nitrogen in the reaction. Okay. Next, in case of hydrogen, we are writing how minus d of H2 divided by dt. It means it is the rate of disappearance of hydrogen in the chemical reaction. Minus d of N2 divided by dt is the rate of disappearance of nitrogen in the chemical reaction, whereas minus d of H2 divided by dt is the rate of disappearance of hydrogen in the chemical reaction. Now we compare. In the chemical reaction, you see if 1 mole of nitrogen is participating, 3 moles of hydrogen is participating. Means if 1 mole of nitrogen is disappearing, 3 moles of hydrogen will disappear in the same time. So the rate of disappearance of hydrogen in the chemical reaction is 3 times to that of the rate of disappearance of nitrogen. The rate of disappearance of hydrogen in a chemical reaction is 3 times to that of the rate of disappearance of nitrogen. That you have to remember. Okay. Next, you see the second case. You see? Rate of reaction. This is a graphical representation of rate of reaction. We can express the rate of reaction in terms of both reactants as well as products. So on y-axis we have considered the concentration, on x-axis time. What happened to the concentration of reactant? In the beginning they will be very high. Gradually they will decrease. How the decrease is? The decrease is exponentially. Similarly, how the products are, concentration of product is 0 in the beginning. Is it? Gradually it will increases exponentially. The amount of the concentration of reactants decrease exponentially with time. The concentration of products increases exponentially with time. This is a graphical representation of change in concentration of reactants and products. Let me see this one of the problem given here. One of the problem given here to us. For a chemical reaction, the decomposition of nitrogen pentoxide, it gives what? Nitrogen dioxide and oxygen. So in this question it is given like this, you see. These points are given. The rate of disappearance of nitrogen pentoxide is a given data. The rate of disappearance of nitrogen pentoxide with time is equal to K into N2O5. The rate of formation of NO2 with time is equal to K dash into N2O5 concentration. The rate of formation of oxygen is K double dash into N2O5 concentration. Now here it is asking what is the relation between K, K dash and K double dash. This is a question given to us. It is given for decomposition of nitrogen pentoxide. Okay, so this by 2, how it is possible, you see here. According to this equation, given equation, how can you express the rate of reaction? So minus d of N2O5 concentration divided by dt, is it? For N2O5, 1 mole. How many moles of NO2 is there? 2 moles. That's why you have to write plus 1 by 2 d of NO2 concentration divided by dt. We said that you have to write the reciprocals or the stoichiometric coefficients. That is equal to how many moles of oxygen is there? Only half mole, but you have to express for 1 mole. When it is half mole, you have to write what? Into 2 multiplied by 2. So writing 2 into d of concentration of O2 divided by dt. Means we are expressing the rate of reaction in terms of change in concentrations. Change in concentrations. Next, you can substitute now. You can substitute here. Here you can substitute. What is d of N2O5 concentration divided by dt? It is given what? Instead of this, it is given K1 or K dash K. What is d of NO2 divided by dt? It is given as what? K dash into concentration of N2O5. Concentration of N2O5. It is given like this. Similarly, what is the rate of formation of oxygen? It is given. It is given instead of this we are writing. Instead of this, what we are writing? We are writing it is K double dash into concentration of, that is N2O5. Concentration of N2O5. We can write it. So when we are equating all these equations, what happens? What happens? You can see here N2O5 concentration is common in all sides. Is it? It is common in all sides. So here it will be cancelled, here it will be cancelled, and here it will be cancelled. So what we get? K is equal to 1 by 2 K dash 2 into K double dash. K is equal to 1 by 2 K dash means what? K dash is equal to 2K. So you can see K dash is equal to 2K. Actually K should be there, is it? K dash is equal to 2K. Next, you see here, what is the relation between this K and K double dash? K is equal to 2K dash, K double dash. You can see here, is it? You can see, you can compare both of these. K is equal to 2 into K double dash. K is equal to 2 into K double dash means what? K double dash is equal to K by 2. K double dash is equal to K by 2, is it? K by 2, here you can see. K double dash is equal to K by 2. Like this, we can establish the relation between, what? Constants which are existing in that line. So this is about N2O5. Is it clear? This is the given data. This is the given data. We are writing the rate expression in terms of change in concentration. Then we are substituting these values in that chemical equation. Sorry, in that mathematical equation. Then we can establish the relation between K1, K2 and K3, or K dash into K double dash. Next, another example you can see here. 2 moles of sulfur dioxide react with 1 mole of oxygen to give 2 moles of sulfur trioxide. How can you write the rate of reaction? How many moles of sulfur dioxide is there? 2 moles, but you have to write for 1 mole. That is a reactant. Since it is a reactant, you have to write only for 1 mole. We have to write what? Minus before that. Yes, minus before that. Then 2 moles is there, you have to consider for 1 mole means half of it, means 1 by 2. Reciprocal of what? Reciprocal of stoichiometric coefficient. Similarly, 1 mole of oxygen, okay, 1 mole. 2 moles of sulfur dioxide, there is a plus 1 by 2 since it is a product. D of concentration of SO3 divided by dt. So in this case, if you compare both of these, you see, the rate of disappearance of sulfur dioxide is exactly equal to rate of formation of sulfur dioxide. From chemical equation also you can understand. Next, and you also think about the oxygen and sulfur dioxide. You see, oxygen and sulfur dioxide. The rate of disappearance of oxygen is half of the rate of disappearance of sulfur dioxide. The rate of disappearance of oxygen is equal to half of the rate of disappearance of sulfur dioxide. If 1 mole of oxygen disappears in the chemical reaction, that means that participates in the chemical reaction. How many moles of sulfur dioxide is participating? 2 moles. Mean the amount of oxygen consumed is, in terms of number of moles, if you say, it is exactly half to that of the amount of sulfur dioxide that consumed in the chemical reaction. Like that we can understand the concept. You see this here again, what we said here, if 0.5 mole of SO2 is consumed, then what amount of oxygen consumed? It is 0.25 because the ratio is 2:1. 2 moles of sulfur dioxide, when it participates, 1 mole of oxygen is 2:1. So when 0.5 mole of SO2 is consumed in the reaction, the amount of oxygen consumed will be equal to 0.25. 0.25 moles. Like that we can establish the relationship. Okay, this is how to express the rate of reaction in terms of concentration change. Right, we say that we are expressing the rate of reaction in terms by using the differential equations. So what are the important points? First one, but express the rate of reaction only for 1 mole in this method. What is second point? In case of reactants, you have to write the minus before the expressions. In case of products, you have to write plus before the expression. Third point is we can express the rate of reaction in terms of or with respect to any one of the species that participate in the chemical reaction. That is the third point. Now, what is meaning of rate law and what is meaning of rate constant, that we discuss. How the rate law and rate constant are arrived. How can you decide it? What is meaning of rate law? That you have to see. Remember, the rate law is expressed by make use of law of mass action. What is meaning of law of mass action? Law of mass action is nothing but it explains the relation between the rate of reaction and concentration terms present in that reaction. The rate of reaction and concentration terms. It gives the relation between these two. So according to law of mass action, the rate of reaction at any instant is directly proportional to the product of active masses of reactants present in that reaction at that instant. For example, you see here 2H2 plus 2NO gives N2 plus 2H2O. According to that, suppose if it is a reaction, for that can we write? According to law of mass action, we can write like this. But can we write it or not? That you have to see. Means based on chemical reaction, can we write a rate expression according to what? Law of mass action or not? So what is the law of mass action? The rate of reaction is directly proportional to the product of active masses of reactants present at that instant. That is the law of mass action. So according to law of mass action, when you are writing the rate of reaction and concentration terms, you remember the stoichiometric coefficients should be raised as powers. So in this expression, you can see here, if the concentration of hydrogen is doubled, what happens? When the concentration of hydrogen is doubled, means the concentration of hydrogen is increased by 2 times, it becomes what? 2 power 2. 2 power 2 means how many times the rate will increase? It should increase by 4 times if you are not disturbing the concentration of nitric oxide. Is it? So when the concentration of hydrogen is increased by 2 times, the rate becomes 4 times. According to this equation, what we are representing here. Actually, it happens or not, that we see in later. Next, you see about nitric oxide. If you are not disturbing the concentration of hydrogen, and if you are increasing the concentration of nitric oxide by 2 times, then what happens? Again, the rate of reaction will increase by 4 times. Suppose nitric oxide concentration increases by 3 times, then what happens? 3 square, because the nitric oxide term is having the power 2. You are increasing the concentration of nitric oxide by 3 times, means 3 power 2. How many times the rate will increases? 9 times. So is it happening actually in this reaction or not? That you have to see. You have to see the data collected in case of this reaction. And studying the concentration effect on rate law, you see the hydrogen concentration, nitric oxide concentration and rate. Initially, H2 is taken 1.0 mole per liter. This is 1 m. What is the rate? 1 into 10 power minus 4. Now here the concentration of hydrogen is kept constant, but the concentration of nitric oxide increased by 2 times. Are you observing or not? Concentration of nitric oxide increased by 2 times. Then you see the change in rate. How many times the rate of reaction is changing? It increases by 4 times. It increases by 4 times. Means when you are increasing the concentration of nitric oxide by 2 times, the rate of reaction is increased by 4 times. Can you guess what is the power of nitric oxide concentration terms? Yes, you can. It will be equal to how much? 2. Power will be 2. What is the quotient of stoichiometric equation? The stoichiometric equation. It is also 2. It is coinciding here. Okay, you leave it now. So, the power of nitric oxide is equal to how much it is? The power of nitric oxide is equal to 2. It is equal to 2, right? Next, now you see how to decide about what in terms of, in case of hydrogen. In case of hydrogen, now you compare the second and third sets. In second and third sets, the concentration of nitric oxide remain constant, whereas the concentration of hydrogen is doubled. Okay. When the concentration of hydrogen is doubled, now you see change in rates. The rate of reaction increases by 2 times. By keeping the nitric oxide concentration constant, if you are increasing the concentration of hydrogen by 2 times, the rate of reaction is increasing by 2 times. Means if you increase 3 times, it also will increase 3 times. Can you predict the power? Power is nothing but what? 1. But in the stoichiometric equation, what is the quotient? It is 2. It is not coinciding here. Yes. Then you see, you can compare this. You can compare the first and last one. First and last one. You can compare both these first and last sets. First and last set. There is no change in concentration of nitric oxide. Are you observing or not? Yes. But we are increasing the concentration of hydrogen by 3 times. Now you see, the rate of reaction increases by 3 times. So when you are increasing the concentration of hydrogen by 3 times, the rate of reaction increases by 3 times. It happens only if the power of concentration of hydrogen is 1. So the power of concentration term of hydrogen is 1. The power of concentration term of nitric oxide is 2. But you see the coefficients. The quotient of hydrogen is 2 only, but power we got 1. The quotient of nitric oxide is 2. Here also we get 2. So finally, we say the rate of reaction is like this. Rate is directly proportional to concentration of nitric oxide power 2. And rate is directly proportional to concentration of hydrogen. So overall rates with respect to these reactants, how can we write? Rate is directly proportional to nitric oxide power, concentration power 2 and concentration of hydrogen. Is it? Next, concentration. Next, so here the proportionality constant is there. Is it? Proportionality constant is there. When the proportionality constant is there, you see, here we can write like this. The proportionality constant is what? K. The proportionality constant is K. Now this K is called as specific rate or rate constant. This total equation, now we call it as rate law or rate equation. What we say? Rate law or rate equation. K is called as rate constant or specific rate. Here one important point you have to remember. The rate constant K does not depend on concentration. It depends only on the temperature. Means when you are changing the concentrations of reactants, K will not alter, K will not change. K will not change. So when you change the temperature, then K will change. Means K depends on temperature of reaction. It is independent of concentration terms, concentrations of the reactant which are present in the reaction. K is called as specific rate or rate constant. So from this discussion, how can you arrive the rate law? Can you say now? How can you arrive the rate law? The rate law is derived. Rate law is arrived based on experimental evidences, is it? This experimental evidence, is it? So rate law is arrived based on what? Experimental evidence. That is very important. By simply observing the chemical reaction, we cannot write rate law. It will be arrived based on experimental evidences, experimental studies. Okay, so like this we can express the rate of reaction according to what? Law of mass action. In the law, when you are expressing the rate of reaction according to law of mass action, that represent the stoichiometric coefficients as the powers of what? Reactants. The stoichiometric coefficients of the reactant should be represented as what? Powers of concentration terms. That is a method. Okay, so in two methods. One, we have expressed the rate of reaction in terms of concentration change. Second, we can express the rate of reaction according to law of mass action. Here we write the rate equation. The rate equation is arrived based on experimental studies. So let me discuss about the factors influence the rate of reaction. Which factors will influence the rate of reaction? They are the factors: concentration of reactants, effect of temperature, pressure, medium of reaction, radiation, and catalyst. So these are the factors that influence the rate of reaction. So we discussed this in second part of chemical kinetics. Thank you.